when we're dealing with carboxylic acids, right?
Yeah.
So, see, understand. So, let's say we have CH3, COOH group. So, I hope you're understanding that these lines between the atoms are what, right? So, we have CH3, COOH. So, this is what? This is ethanoic acid, yes or no?
Yes.
So, I hope you're understanding that when we have ethanoic acid, right? So, you can have COH being repeated here. You can see that happening, right? So, let's say if I say CH3, CH2, COOH. So I'm going to compress it and I'm going to condense it to CH3, CH2, COOH. And that is nothing but what? That is propanoic
Mm-hmm.
acid. So out of anything else that is coming up here, we have these terms, right? So we are going to have R. What is R represents? R represents a long chain of carbon atoms. A long chain of carbon atoms. Yes or no? So when R
Yes.
represents a long chain of carbon atoms, what does that mean? That I'm going to say that one thing that remains common in all the carboxylic acids is COOH group, which structurally looks something like that. Are we understanding? So when
Mm-hmm.
it structurally looks
Yeah.
something like that, so how does it work for you? See, understand. So if I say that all carboxylic acids are acidic and turn blue litmus red. Yes or no? So it turns blue litmus red. So when we say
Yes.
that it turns blue litmus red, what does that mean? So you have R, C, O, O, H. Are we understanding? So we have this electron here. So when you have this OH line, when you have this OH line here, you get it. So what does
Mm-hmm.
that mean? What does that mean? So when you have this OH line here, what exactly does that mean? So we're going to have R, C, O, O, and H plus is lost. Why? Because you understand you have to remember one specific order. And what is that specific order? It is fluorine, chlorine, bromine, iodine. Yes or no? So what do you think we'll have? We'll have fluoro, chloro, bromo, and iodo. Yes or no? So we'll have fluoro, we'll have chloro, we'll have bromo,
And I do.
and iodo. So all of these groups. And similarly, if I have phone call order, like this kind of order. So you have to remember that these are the topmost strongly electronegative elements of the periodic table. So if we have 118 elements in the periodic table, yes or no? So if we have 118
Mm-hmm.
elements in the periodic table, what do we see here? We will see here that fluorine is the strongest electronegative element. What do you mean by being the strongest electronegative element? That it pulls electrons towards itself, right? It pulls
Yeah.
it pulls electrons towards itself. And then when it pulls electrons towards itself, what exactly does that mean? Then we'll have oxygen, then we'll have nitrogen, then we'll have chlorine, then we'll have bromine, and then we'll have iodine. Are we understanding?
Yeah.
So I hope you're understanding that whenever we have a bond, so these elements are the elements which are tending to attract the electrons towards themselves. So I hope you're understanding that when we have OH bond here, the electrons will be pulled towards O. One electron in the bond belongs to H, right? The cross electron. And one electron here belongs to dot. So what does that mean? What does that mean? Just tell me. So we have this bond and the electrons get shifted towards O and H. Got it?
Yeah.
So then what is happening? Just tell me. Then what is happening? Just tell me. That this electron, when it breaks, O pulls its own electrons and O also pulls the hydrogen's electrons toward itself. So thereby you realize the fact that R, C, O negative. So this O carries a negative charge. Yes or no?
Yeah.
So when this O carries a negative charge, what would that mean? When this O carries a negative charge, what would that mean? Just tell me. That this is going to break it like this. And anything which can release H plus is nothing but what? An acid. So how do you define that and how do you prove that carboxylic acids are acids? So you will say that when you look at the structure of RC double bond OH, when you look at this structure and when you break this bond, so what do you realize? So we'll have RC double bond O negative, and H positive. Yes or no? So I hope you're understanding that when this bond specifically breaks, when this bond specifically breaks, right? So O is carrying its own electron, also it carries its own electrons cross. So we will have what? So we'll have RCOO negative, and this is going to be my carboxylate ion. This is going to be my carboxylate ion, and along with it, it is releasing H plus. So any substance which releases H plus, any substance which releases H plus is called as an acid. Are we understanding, Aaron?
Mm-hmm.
Right?
Yeah.
And any acid, if it is an acid, it reacts with a base to form salt and water. So one specific reaction that we have here, just understand. So if I say CH3, COOH, and I make it to react with NaOH. Now understand why NaOH specifically. Because you have substances like KOH, you have substances like CaOH whole twice, you have substances specifically like AlOH whole thrice, you have substances like NaOH, you have substances like NaOH or LiOH. So when you have these substances KOH, COH whole twice, AlOH whole thrice, NaOH, LiOH, yes or no?
Mm-hmm.
So what do you mean by this? Right? What does that mean? So I'm going to break it down like this. I'm going to break it down. So how does AlOH whole thrice break? It breaks down like Al plus 3 and OH minus 1. NaOH breaks like Na plus and OH negative. LiOH breaks like Li plus and OH negative. So all of them will have, you see, hydroxide ion common. Yes or no?
Yeah.
So when they have this hydroxide ion common, what does that mean? KOH will break down like K plus and OH negative. Got the point? So what do you
Mm-hmm.
think we have in here? We have these cations and one a negative ion which is hydroxide ion remains common in all the compounds. Yes or no? And such substances which
Mm-hmm.
have OH negative ions are called as nothing but what? They are called as bases. Are we understanding? They are called as bases. Or I would also call them as alkalis because these alkalis are bases which are soluble in water. Which are soluble in water. Understood. So if I break this down Na
Mm-hmm.
plus and OH negative, and if I break down CH3COH, so I hope you're understanding this is how they break. O will pull the electrons towards itself. It's O is electrons and H is electron. Yes or no? And if I'm going to break NaOH, it is going to break down like Na plus and OH negative. Got the point? So negative here goes with positive and positive here goes with negative.
Negative.
So if this happens, because obviously there's an exchange of the ions taking place, so negative shall exchange itself. Negative of one will exchange itself with the positive of the other, and the
Mm-hmm.
positive of one shall exchange itself with the negative of the other. So what do you get in here? You get CH3COONA, and you also get H2O. Are we understanding? Because obviously we have two
Mm-hmm.
ions being formed here. CH3, COO negative is getting crisscrossed with Na plus. LH plus is getting crisscrossed with OH negative. Yes or no? So crisscross means what?
Mm-hmm.
You make a compound whereby a negative ion attaches itself to the positive ion. So whenever a negative ion attaches itself to positive ion, I hope you're understanding that, when a negative ion attaches itself to positive ion, highly likely the final compound has to be neutral. The final compound has to be
Mm-hmm.
neutral. So when the final compound has to be neutral, what does that mean? Tell me. So we will have CH3, COONA, and we are going to have H2O. Understood my point or not?
Mm-hmm.
Yes or no? So that's the idea
Yeah.
that we have. So we're going to have CH3CONA plus H2O, and that's the place. Got it?
Yeah.
So this is called a sodium acetate. So you have to understand one very important part, that if I give you any carboxylic acid, let's say if I give you CH3, CH2, COOH, and I expect you to complete the reaction with KOH, how will you frame the reaction? You will break this down. KOH is potassium hydroxide. KOH is potassium hydroxide, and here I'm going to break it down like this. So here negative goes with
Mm.
positive, and positive goes here with negative.
Negative.
So what do we do here?
It would be CH3CH2 cook and then
This
white water.
potassium, yes, and this is water. So this is going to be potassium propanoate.
Cook water.
Got it? Any
Mm-hmm.
difficulty in this reaction?
No.
Now, very simple. How do you write down the name of the compound? See, you always write down the name of the positive ion first, followed by the negative ion. You always write down the name of the positive ion first, followed by the negative ion. Got the point?
Yeah.
So, when you follow the name of the positive ion along with the negative ion, what does that mean? Just tell me. So, how do you write down? Let's say if I have, understand one thing. If I have HCOOH, this is my carboxylic acid whose name is methanoic acid. Okay.
Yeah.
So if I know the name of the carboxylic acid, and I definitely know it is going to break from here, so I'm going to have an ion, negative ion here, and H plus being released. So the name of the negative ion will be formed how? Simple. From methane, replace OIC with OH. So the name becomes methanoate. Are we understanding?
Mm-hmm.
So it's not difficult. It's very simple. That you what do? You replace methanoic acid with methanoate. Understood?
Yes.
So if I have CH3, COOH. So I will have what? I will have an ethanoic acid. So
Mm-hmm.
how do you write down? You know that it is going to break like this. So it is going to form CH3, COO negative plus H positive. So ethanoic. So you replace oic with what?
Mm-hmm.
Ethanoate. So the name of the negative ion comes from the name of the negative ion comes from where?
Mm-hmm.
It comes from
It
the
comes from
acid's
the
name. And all you do
acids.
is you
Yeah.
replace oic with OH. Simple. So if you look at this was my propanoic acid.
Now becomes propanoate.
Yes. And then how do you write down? And potassium is potassium. K is potassium, right? So we write down the name of
Right.
the positive ion followed with the negative ion. So positive ion is potassium, propanoate is negative ion. So the
Mm-hmm.
salt, this becomes a salt. Because if you look at the positive ion shouldn't be H plus. Because the moment the positive ion becomes H plus, it becomes an acid. Yes or no? And similarly, the negative
Mm-hmm.
ion becomes an OH negative, it becomes a base. Are we
Mm-hmm.
understanding?
Yeah.
Got it? So that's the idea that we have. So we're going to have propanoic acid to this. Understood my point or not?
Yes.
So that's the point. So look at this value. So let us suppose we have what? So we have this value, right? Got the point.
Yeah.
So now look at this value. So let's suppose if I have CH3, CH2, or any carboxylic acid, the primary carboxylic acid just that we generally use is CH3COH. Now I want you to write down its reaction as NaHCO3. What is the name of NaHCO3? Na is sodium, and the anion here is HCO3 negative. So its name is bicarbonate radical. So it's sodium bicarbonate, and you obviously know that how do you break this down? You break this down here between O and negative and H positive. So the negative part
Mm.
goes with the positive part of it. The negative part goes with positive part, and the positive goes with negative. So what do you think I'll get it here? I'm going to get CH3, COONA. And H plus shall go here with HCO3 negative, so it forms H2CO3. How does H2CO3 forms? H2CO3 gives me H2O.
H2O and CO2.
Yeah. And we have CH3, COONA. How do you name this compound? It's a salt,
That's
obviously.
going to be
See, what is a salt?
sodium ethanoate.
Yeah, exactly. The name is sodium ethanoate because it is coming from the acid which is ethanoic
Acid.
acid. Got the point?
Yeah.
So that's sodium ethanoate. Got it?
Yep.
So that's the idea we have. Now, similarly, what do we have in here? Just understand. So primarily we're going to have this, right? CH3CONA plus H2O plus CO2. Got it? Now, similarly, if I carry out the same reaction, I'm going to carry out the same reaction with CH3COOH, which is nothing but my ethanoic acid. I am going to react it with Na2CO3. So, how do you carry forward the reaction? If I break this down, I'm going to get Na plus 1. I'm going to get CO3 minus 2. And that's how I'm going to break this down. So, negative here goes with positive. Positive here goes with CO3 minus 2. So, I'm going to have CH3COONA. And you crisscross H plus with CO3 minus 2. So, what do you think you'll get?
Um, CO3 minus 2, then Na plus. Wait, minus 2, that means you'll have 2 Na. Wait, wouldn't that be like when you carry the H over, it's gonna be like H2.
So, we're going to have H2CO3.
Yeah,
Got the point?
yeah.
So, we're going to have H2O plus CO2.
CO2. Mm-hmm. And then Chikuna. What's all? Mm-hmm.
Got the point?
Yeah.
So, it is going to break down like what? H2O and CO2. Understood the point?
Mm-hmm. Yes.
Got the point? So, we're going to have what? We're going to
Mm-hmm.
have CH3CONA,
Mm-hmm.
and that's the part. Are we understanding? So, CO2 gas
Mm-hmm.
comes out here with a lot of bubbling. CO2 gas comes out here with a lot of bubbling.
Mm-hmm.
Got it?
Yeah. Mm-hmm.
Yes or no?
Yeah.
So that's another reaction. So that's how it works, that.
And then the ethanoate would be what?
So this is again going to be sodium ethanoate.
Yeah, but like, what is it? Like,
It's a salt.
just salt. Oh yeah, salt,
Why
salt,
it's a
right?
salt, I'll
Acid,
tell you. If you have, let's say,
acid plus salt. Acid plus metal equals salt. Acid plus carbonate equals salt. They all equal. Yeah.
got it. So let's
Yeah,
say
yeah.
let's say see, if I give you HCl, if I give you H2SO4, if I give you HNO3, if I give you HBr, so what exactly happens? So you're going to have this, right?
Yeah.
So all of this has a cation as H plus. So if anything has a cation H plus, it is going to be hydrochloric acid, sulfuric acid, nitric acid. Got it?
Uh-huh.
So if I say NaOH, if I say KOH, if I say LiOH, all of them have the anions as
That's a OH.
lots of OH.
Hydroxide.
Yeah. So the point is that we have all of this, right? So there would be bases. Now you look at this part. So cation is Na plus. So cation is anything but not H plus. And anion is CH3CO negative but not OH negative. Are we understanding?
Mm-hmm.
So cation could be anything and anion could also be anything. Got it?
Mm-hmm.
So what does that mean?
Mm-hmm.
What does that mean? Tell me. That whenever cation is any cation but not H plus,
Mm-hmm. Mm-hmm.
and anion is any anion but not OH negative. So that compound is a salt. Do you understand? That compound is a salt. Understood the point or not? Got it or not? So when we are dealing with this, a cation is any cation and anion is any anion but not OH negative. That is a salt. So obviously this is a salt. And here CO2 is released with a lot of bubbling. So what do you call? This is basically effervescence. This is a
Mm-hmm.
lot of effervescence. Understood? So basically all the acids they would react with the base. All the acids are going to react with sodium carbonate or sodium bicarbonate. Yes or no?
Yeah.
Got it. Next, what do we have? Next, we have
Mm-hmm.
decarboxylation. Now, when we have decarboxylation word means removal of CO2. So, from all the carboxylic acid, let's say if I say CH3, COH, what I'm supposed to add? I'm going to add
Mm-hmm.
NaOH and I'm going to add CaO. Got the point? So, I'm going to put
Mm-hmm.
these two. So, NaOH is called as what?
Yeah.
Caustic soda.
NaOH is
And CO is going to be called as quicklime.
quickly.
Quicklime, yeah. Which is also
Quick
calcium
lime.
oxide. So calcium
Quick
oxide is
lime.
its chemical name and quicklime is its uh,
Um,
common name.
that's like
Yeah.
the common name, yeah.
Yes. Now, see, understand. So their reaction happens here. Got the point? So you
Yes.
break this down. So you have negative going with positive and positive going with negative. So what does that mean? So it is going to be CH3, COONA, and we're going to have water. Got the point?
Yeah.
So this is going to be a cha. So now basically what happens is not you're not going to perform this reaction. When you add CO along with it and you heat it, heating is very important. So then what happens is you realize that this CO2 molecule gets removed. So this CO2 molecule gets removed and this H comes here. So we are going to have a CH4 molecule and CO2 molecule gets removed. Are we understanding?
Yes.
Got the point? So that's how it works.
Yep.
Understood. So it's very simple. All you have to do is add NaOH and add CO and heat. So you remove CO2 and you put H here.
Mm-hmm.
So you're going to have ethane. So what are we doing? We are having a 3 carbon carboxylic acid. That's propanoic acid. And from there on, you're removing this CO2 and you just fix this H and connect here. So you get CH3, CH3. Understood my point? So similarly, let's say you have CH3 like this. So you'll have NaOH and you will have CaO and you will have heat. So what exactly is going to happen? We're going to have CaO and this H comes here. So you're going to have CH3, CH2, CH3. So this is going to be
Mm-hmm.
got the point.
Yeah.
Got the point. So we have this,
Mm-hmm.
right?
Yeah.
So that is decarboxylation. Now what happens is that whatever CO2 is being produced, whatever CO2 is being produced gets absorbed by NaOH. So NaOH, the use of NaOH here is to absorb all the CO2. Are we understanding?
Mm-hmm.
That's the that's the part.
Mm-hmm.
CO2 being
Yeah.
produced gets absorbed by NaOH. So that's the idea we have.
Mm-hmm.
Got it?
Mm-hmm.
So now another reaction. Next we have the reduction reactions. When we are dealing with the reduction reactions, so all carboxylic acids convert to alcohols on the addition of the reducing agents. All right. So how do we have this? We have two reducing agents, two primary reducing agents that we use, and there are a lot more reducing agents that we have. But two primary reducing agents that we're going to have with us is LiAlH4, which is called as lithium, aluminum hydride, and we're going to have NaBH4, which is going to be sodium borohydride. Are we understanding? So with us, we are going to have lithium aluminum hydride, and we are also going to have our sodium borohydride. Two very important reducing agents, and they're both white powders. If I ask you which is a better reducing agent, I would say LiLH4 is a stronger reducing agent that we have. Are we understanding?
Yeah. LiH. Lithium, aluminum,
Got the point. Now understand. Now
hydride.
very important thing to remember here that LiLH4. So you're going to have LiLH4. So you're going to have Li plus ALH4 negative. Got the point. So if you have
Yes.
ALH4 negative, that's going to break down as ALH3 plus H negative. Got the point,
Yes.
right? So this H negative. So anything which can give off H negative or any kind of hydrogen, is not necessarily always H negative. It possibly could be a neutral hydrogen. It possibly could be an ionic hydrogen. Any hydrogen it is giving me off. All I get is that a lithium aluminum hydride. Got the point? So you have a look here. So we'll have CH3COOH and LiLH4 I put it into it. So nothing happens to OH, right? So you know that how LiLH4 breaks down. It breaks down into two cations and anions. That anion further breaks down into a neutral compound and a anionic hydrogen. Now we replace this H, this O. So there is a removal of oxygen, and in place of oxygen there is an addition of two hydrogens. So this becomes CH3. Now the two bonds of carbon, the two bonds of carbon remains like this, and we have this. Are we understanding? So we are going to
Mm-hmm.
have CH3, CH2, OH, and that is nothing but what? That is ethanol. Understood my point or not?
Yeah.
Got it? So that's the idea
Yes.
we have. That's the idea we have. So we're going to have ethanol. Got the point?
Mm-hmm.
So that's LiAlH4.
Mm-hmm.
So in place of, so basically one oxygen gets replaced by two hydrogen,
Mm-hmm.
gets replaced by two hydrogen. Got the point? So from here, what are you getting? From ethanoic acid, from ethanoic acid to
Mm-hmm.
ethanol. Got the point? From ethanoic acid to ethanol. Now, similarly, let's say if I have CH3, CH2, COOH. So basically, the idea here is what? That when I add LiAlH4, which is lithium aluminum hydride, right? So what am I doing here? I am having LiLH4, right? What do I do? I
Mm-hmm.
remove two, I add two hydrogen in place of one oxygen. So this oxygen, which is doubly bonded to the carbon, gets replaced by two hydrogens. Are we understanding?
Mm-hmm.
Any doubts on this?
Mm-hmm. I know. Understood.
Right. So a direct, if I say a direct method, I would say keep the CH3 CH2 part as it is because that has got nothing to do with the reduction part. Entire reduction is happening here, only in this group. So all I do is I replace this, I substitute this with CH2OH group. So all I can say is remove COOH group and substitute it with CH2OH group. Are we understanding the point?
Mm-hmm.
And
Yeah.
substitute it with CH2OH group. Understood or not? Got it? Any doubts in this? Just tell me.
Yeah. No, understood. There's no doubts.
You understand the point?
Mm-hmm.
So that's the idea that we have with us. Got it?
Mm-hmm.
So
Yeah.
that's the part. So remove COH and substitute it with CH2OH group. So let's say if I have CH3, CH2, CH2, COOH group. Again, this time I'm going to have what? I'm going to have butanoic acid. So if I'm going to have butanoic acid, what does that mean? I'm going to add LiLH4 to it, or if not LiLH4, at least NaBH4. So when you have this, you replace COOH with what? CH3, CH2, CH2, and you replace COOH with CH2OH. So this is going to be nothing but what? This is going to be butanol. Got the point? That's how the reaction is
Yeah.
basically done. So this is a reduction reaction of carboxylic acids. One reaction, next reaction that we have is one reaction that we have for carboxylic acids is reaction with sodium. All right. So when we have this reaction, which is reaction with sodium, it basically means what? Just understand. So when we are dealing with the reaction with sodium, what does that mean? So we're going to have CH3, COOH. Do you realize? And I have sodium with it. So understand if I have the reactivity series iron, we have potassium, sodium, calcium, magnesium, aluminium, silicon.
Mm-hmm.
CuHgAgAuPt. That means gold and platinum. So you look at the value that H lies here and Na lies here. So Na is definitely a more reactive metal. Na is definitely a more reactive metal than H plus. Yes or no?
Mm-hmm.
So if Na is
Yeah.
more reactive metal than H, what does that mean? Just tell me. If Na is a more reactive metal than H, what does that mean? Tell me. Then I'm going to break this down. So we're going to have COOH. Got the point?
Yeah.
So you understand that sodium is atomic number 11. So configuration here is going to be 281. So when the configuration we have is 281, what does that mean? That one
I mean,
electron
there's
can be
one
lost.
extra
So
electron.
how does it basically do? Na is a reactive. See, I'll tell you a very simple story. So Na, you consider it as a very rich person. A very rich person can obviously, and H is also one person and Na is also one person, but Na is richer than H. So do you realize that Na has all the power in the world to snatch anything from H? Because Na is like the head or the head of the company, and H is just the employee of that company. Do you realize that?
Yeah.
So if H plus has this anion with itself, highly likely that if Na wants to connect with this, and obviously Na what would want to connect with it. Why? Why would Na want to connect with it? Tell me.
Would it be anion or cation?
Na is a metal. It has 281. So obviously it is going to lose one, right? Initially it has 11 protons is
No, I'm
equals to
talking
11
about the
electrons.
hydrogen. No, 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 no.
So because of its configuration 281, it is going to lose one. So if it is going to 281, if it is going to lose one, what does that mean? Tell me.
And again, a positive charge.
Yeah. So Na would like to have the or acquire a space. Na would like to acquire the space of H plus. Got the point? And when Na wants
Yeah.
to acquire the space of H plus, what would that mean?
It would mean that H plus will become neutral.
Yeah.
Na will
So
take
Na is going to
will be
lose one
rather
specific
control.
electron and Na is going to give its electrons to H plus. Are we understanding?
Yeah.
You get it? So when Na is going to give
Uh-huh.
its electrons to H plus shall become neutral. And obviously when H plus becomes neutral after gaining that electron, automatically the neutral will not have an attraction with the negative. You get the point?
Mm-hmm.
So what do you expect? So we're going to have CH3COO negative, and that is going to have an attraction with Na plus. And H will release as hydrogen. So you understand that why hydrogen is getting released? Because it came from the acid. And all acids, that they have H plus ions with them. Yes or no? All acids would have an H plus ions with them. Any doubts in this?
Mm-hmm. No,
So I
understood.
hope you're understanding that when we have this reaction with sodium, hydrogen gas is released, which burns with a pop sound. Are we understanding or not?
Mm-hmm. Yeah.
Got it?
Mm-hmm. Yeah.
So that's the idea we have. So when we are dealing with the reaction with sodium part, we have this specific reaction. Understood my point?
Mm-hmm.
Got it?
Yeah. Yes.
So that's the idea we have. Got it or not?
Mm-hmm.
So we have more reactive metal than H. We have the reaction with sodium. So we have this. Understood or not?
Yeah. Understood.
Right. So if I ask you to make a reaction between another reaction between CH3, CH2, COH. So it's a three carbon carboxylic acid. This is nothing but what? This is propanoic acid. And now
Yeah.
if I ask you to make its reaction with calcium. So do you realize that calcium is obviously in the reactivity series it is potassium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, Cu, Hg, Ag, Au, Pt. So obviously That calcium lies here. And that calcium will do what? That calcium will do what? Tell me.
The
That
calcium will
calcium is negative
uh
and it's positive.
the calcium is a group.
So calcium is going to be atomic
um,
number 20. So its configuration is
no, it's
2882.
group two. It's group two.
Yeah. So it's going to lose two electrons.
Yeah, so it becomes a hydrogen atom if you move the calcium to the other side.
So calcium is this and hydrogen is this. So obviously the one at the top is definitely richer.
Uh-huh.
And the person who is richer at the top would donate its electrons to H. So we're going to have what? We're going to have CH3, CH2, CO negative, and we'll have Ca plus 2. And we'll have two H neutrals that we're going to have. And when we are going to have this crisscross, I hope you're understanding what do we have. So we'll have CH3, CH2, COO whole twice, Ca. And from here, hydrogen gas shall be released. Are we understanding?
Yeah,
So that's the idea that we have. Understood my point or not?
understood.
Got it?
Yeah.
Got it?
Yeah, got it.
So that's how we have these reactions. I hope you're understanding that obviously to neutralize 2 calcium plus 2, we have one
Mm-hmm.
anion. Yes or no? Are we understanding?
Mm-hmm.
So that's the idea we have. Got the point?
Yeah.
So can you make one more equation for me if I give you? Let's say if I give you,
Okay.
let's say if I give you, and if I ask you to make an equation with potassium, can you complete the reaction? Is what? I'm going to have here, you get the point. So that's what we have with us.